Hello everyone, I'm Tim, this is Alan. Welcome to the presentation of our project, GPTeam. So we know that language models can code, for example, GPT-4 and GitHub Copilot. They are amazing coding assistants. However, these tools require specific and well-defined prompts, and they generate modular code snippets. So the users of these tools are usually developers and engineers who knows how to code already. But what if the users do not know how to code? They have no idea about how to build a software. So in that case, they can only start with abstract and high-level instructions. But what they need is a complete and operational program. This is why we want to build GPTeam.
GPTeam, in short, is an application for source code generation. It integrates different role and background context. But what makes it so different is that it will utilize the power of GPT to actively engage with user, so that the user requirement could be more concrete and comprehensive, and hopefully better source code generation quality. Since it is a huge topic, in this project we only focus on minigame generation. This diagram will provide an overview about the system. To start with, the user will give a simple software requirement. Then the project manager GPT will engage with the user in a feedback loop to generate a detailed requirement. Then the PM GPT will pass the requirement to the developer and QA GPT, and they will generate a source code based on their technical content. We also provide a checkpoint feature so that the user could restart from any stage.
Yeah, let's just do a quick walkthrough using our system. So the system will first prompt the user to enter an initial requirement. The initial requirement could be detailed, or it could be as simple as build a brick breaker game. And then the PM GPT will clarify the genre and features of the game to get a basic understanding of the game. After that, the PM GPT will delve deeper into the specific gameplay mechanics, including aspects like game initialization, player progression, and like objectives, etc. So the PM GPT will iteratively refine and clarify these requirements with the user until the user is satisfied. So finally, upon user's approval, the PM GPT will summarize these requirements into a finalized requirement list, and these requirement lists will be passed to our developer GPT for code generation. After the codes are generated, QA GPT will perform a code review and do some debuggings. Finally, our system will start running the game. So that's the brick breaker game.
So how do we evaluate GPTeam? First, we target 10 mini-games. Then for each game, we generate a list of requirements, covering game mechanics, user control, etc. Then both of us will run the generated game and see how these requirements are fulfilled. If there are some disagreement, we talk with each other and give our final judgment. Then we will calculate the requirement record or fulfillment rates to give quantitative result. There are two baseline methods we want to compare. The first one is simply ChatGPT, and the second one is ChatGPT with role profile and chain of thought prompting. For each game and method, we do 3 generations, and we pick the best one to compare.
Okay, let's see an evaluation example. So on the left here are the 9 requirements we identified for the brick breaker game. And on the top here is a game generated by our baseline method, and on the bottom here is a game generated by our system. So we play the game and check if each of the requirements are met. We found that for both games, the requirements in yellow are all met. However, in the baseline game, the game does not show player lives, it does not show scores, also the game does not end properly. Therefore, we can evaluate that the baseline method achieved 6 out of the 9 requirements, and our method achieved 9 out of 9 requirements. So here, this huge table shows our results in the final column compared to the baseline methods. We also evaluated the PM GPT on requirement understanding in the second last column. So we can see that our method just outperformed the baseline methods on all 10 games. So most of the games, majority of the requirements are met. However, for 2 games, the tank battle game and Tetris game, although our system was able to understand most of the requirements, in the final results, only few of the requirements are met. This indicates that there are still limitations in our system to build more complex games.
the overall performance of that GPTeam meet our expectation. It transformed the user instruction to operational code. The PM GPT successfully guided the user to come up with a detailed requirement and summarize them. The developer GPT delivers quality code that meets most of the requirements. The QA GPT does help to reduce bugs and enhance requirement fulfillment. There are many things we could improve. For example, we could provide a user interface for users to update the requirement after running the game. We may also introduce a system architect role and see if it works better in a large-scale project. Finally, we could also adopt iterative debugging on QA based on the user feedback. So that's the end of the sharing. Thank you very much.